Dr. V. Jayalakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE-sponsored MODROB project for VLSI Lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing % of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series Electronics Practicals 3. In today's episode, we will discuss about Fourier series representation of continuous time signals. So, what is continuous time signals? The signal varies continuously with respect to time. So, the Fourier series suitable for the periodic signals. So, the continuous time signal should be periodic, then only we can find the Fourier series. So, in the Fourier series, it is represented with the 3 constants which are A0, An and Bn. So, how to derive these 3 constants from the expression and how to write the MATLAB programming will be discussed on today's episode. Fourier series of periodic continuous time signals. The Fourier series and the Fourier transform are converts the time domain signals into frequency domain signals. The frequency domain signal also called as frequency spectrum or spectra. So, let me consider the continuous time signal x of t with periodic t, that is we are expecting the signal should be periodic signal with period is represented as t. Suppose if we take the periodic signal x of t with its initial period t naught, then we are representing x of t is equal to x of t plus t naught. So, the x of t is repeatedly comes with respect to t naught. So, for every t naught the signal is comes, that is periodic. So, for all t we are representing x of t plus t naught, where t naught is the fundamental period, is the smallest positive value of t, it is a time representation. F naught is represented as fundamental frequency which is inverse of the fundamental period 1 by t naught. Periodic signal, the periodic signal normally represented in 2 forms, one is real sinusoidal signal, another one is complex exponential signal. The real sinusoidal signal is represented as x of t is equal to cos omega naught t plus pi. This is a periodic signal with respect to time. The pi represents the phase shift. Either you can use cosine signal or sine signal. The another one is complex exponential signal which is represented as x of t equal to e power j omega naught t. The e is a exponential form with respect to the frequency we are writing. So, this signal is repeated with respect to time t, where omega naught is a fundamental angular frequency which is represented as 2 pi by t naught. So, 2 pi which is a periodic 2 pi with respect to the initial time t naught, that is the fundamental period, or 1 by t naught can be replaced with the f naught which is a fundamental frequency. So, 2 pi f naught. So, the fundamental angular frequency can be represented with respect to fundamental period as 2 pi f naught, can be represented with the fundamental frequency 2 pi f naught. So, the Fourier series represented with the trigonometric forms, that is the signal x of t can be expanded in terms of sinusoidal components, that is x of t equal to a naught plus summation of n equal to 1 to infinite a n cos 2 pi f n t plus n equal to 1 to infinite b n sin 2 pi f n t. So, where a n, b n and a naught are the constants. A naught is the constant or coefficient of the initial period. A n is the coefficient of cosine signal. B n is the coefficient of sinusoidal signal, where the components cos 2 pi f n t and sin 2 pi f n t should be periodic. If it is periodic, then it should satisfy this condition like x of t. How we are representing the periodic representation for x of t? X of t equal to x of t plus t naught. So, the time is varied with respect to the fundamental period t naught. So, the same way here also we are expecting the sinusoidal signal, that is cosine 2 pi f n t is equal to cosine 2 pi f n of t plus t naught. The cosine signal is periodic with respect to t naught. The another component which is sin 2 pi f n t, the sin 2 pi f n t is represented with periodic sin 2 pi f n of t plus t naught. So, what it represents, the sine signal is periodic with respect to the fundamental period t naught. So, what is f n? F n is the fundamental frequency which is represented with n by t naught. It may be varied with the f 1, f 2, f 3, f 4 till infinite, because this is a harmonic representation, right. So, based on that we can represent the signal, the position of the signal with respect to the fundamental period t naught. So, n can be varied from 0 to infinite. The 0 represents constant, which is a DC component. There is no oscillation. 1 by t naught is the fundamental frequency, 2 by t naught, 3 by t naught up to k by t naught, which are the harmonic frequencies. So, now we will discuss how to find the a naught, a n and b n coefficients. So, a naught, this now we are discussing about the continuous signals, right. So, we have to use the integral representation. So, a naught is the fundamental frequency. So, 1 by t naught, the integral over 0 to t naught, the signal which is your input signal x of t and integrate with respect to dt. The a n coefficient is represented as 2 by t naught 0 to t naught x of t into cos n omega naught into t into dt. The sinusoidal coefficient b n is represented as 2 by t naught integral of 0 to t naught x of t into sin of n into omega naught into t into dt. So, by this expression, whatever your input signal x of t, you substitute here and change your limit, integral limit with respect to the time period, then you can obtain the a naught value. The same case for a n, simply replace the x of t and integrate the normal mathematical functions. If you want to obtain the spectrum response with respect to amplitude and phase, then you can get the amplitude spectrum. To plot the amplitude spectrum, we have to calculate the absolute value of Ck, then you have to plot with respect to the angular frequency. That is, amplitude spectrum is a plot of absolute value of Ck versus the angular frequency omega. The phase spectrum is obtained by the plot of pi of k or theta of k versus omega. So, where the pi k or theta k and Ck represents the integers, it may be any value. So, before using into the Fourier series, we have to know the convergence of the Fourier series. That is, what are the conditions, minimum condition to satisfy to obtain the Fourier series. So, it should satisfy Dirichlet conditions. The first one, x of t is absolutely integral over any period signal of t. The second condition, x of t has a finite number of maxima and minima within any finite interval of t. So, after satisfying this Dirichlet conditions, we can obtain the Fourier series representation. So, this is a Fourier signal of rectangular pulse. We are obtaining the response of this. So, based on the sampling period it will be varied. So, how we are taking the n value? This is n equal to 1, n equal to 2, here n equal to 4. For n equal to infinite you get more or less same signal. So, this is one of the representation. This is a normal sine wave signal, right, but we are sampling at 1 by t, which represents the frequency f1. f1 is equal to 1 by t, that is only one cycle we have per period. Here the signal is represented with 2 by t, which represents 2 sine wave signal, right. This is one, then another signal. So, 2 sine wave signal is represented in this signal. So, here f3 equal to 3t represents 3 sinusoidal signals. So, within the period how many signals we are obtaining, from that we are giving the time period signal. So, this is t, this is 2t, then 3t, 4t we are continuing. So, the t is represented as f1, f2, f3 like that. Now, consider the signal f of t, which is equal to 0 for the period minus pi less than t less than 0. Then the signal is 1 when 0 less than t less than pi. Actually the signal is like this. Okay. So, here I have take it as minus pi, 0 plus pi. So, during this period this is a varying time, this amplitude with this maximum value is 1. Okay. From minus pi to 0 the value is 0, from 0 to pi the value is 1. So, now we have to obtain the constant the coefficient values a naught, a n and b n. So, how do you find a naught? A naught is equal to 1 by t, right, 1 by t integral of minus t naught to t naught f of t into dt, right. So, here what is the period? From minus pi to pi. So, 1 by pi minus pi to pi f of t into dt. So, it further reduced as 1 by pi, okay, minus pi to 0 f of t plus 0 to pi f of t dt. So, here the value is 0, so you can skip it. So, here only you have 1, right. So, I will write it as 1 by pi 0 to pi 1 into dt. So, which is simplified as 1 by pi into t, right. The limit over 0 on pi. So, you get it as 1 by pi minus 0. So, finally, you get pi by pi, which is equal to 1. So, a naught value is equal to 1. Okay. So, we have calculated the a naught value. Now, we will find the a n value. A n is equal to 1 by pi integral of minus pi to pi f of t cos omega n t into dt, right. Now, we will substitute the value 1 by pi minus pi to 0 this value into dt plus 0 to pi f of t into cos omega n t into dt, right. So, now this value is 0 because the f of t value is 0, then only we have to substitute here this value is 1. So, which is equal to 1 by pi 0 to pi cos omega n t into dt. Okay. So, 1 by pi the cos omega n become sin, right. So, sin omega n t. Substitute the limit 0 and pi. Sin pi value is 0, right. So, every term will be 0, sin 0 0 and sin pi value also 0. If suppose if we are writing like this, suppose sin some terms with pi anyhow, odd pi or even pi, it will be 0, then sin 0. So, finally, you get the value as 0. So, now calculate the b n value, the coefficient which is equal to 1 by pi minus pi to pi f of t into sin n t into dt. So, 1 by pi I will write only the upper limit 0 to pi, because minus pi to 0 value the f of t is 0. So, I will take only the upper limit 0 to pi f of t into sin n t into dt. So, now substitute the value 1 by pi 0 to pi 1 into sin n t into dt. So, 1 by pi you take it as sin n t is, after differentiating you get cos n t divided by n, then 0 to pi. If you are substituting the limit 1 by n pi, I take it as out, then cos n pi minus cos 0. So, cos 0 value was 1, right. So, 1 by n pi, this one is cos n pi. Suppose n equal to if I take n equal to 1, then you get cos pi, n equal to 2, then you get cos 2 pi, right, then cos 3 pi, 4 pi, likewise based on the n value you can increase. What is the cos pi value? Cos pi value was minus 1, cos 2 pi value was plus 1, 3 pi value was minus 1, 4 pi value was plus 1. So, alternatively the minus 1 and plus 1 it comes, right. So, for easy understanding or for simplification you write it as minus 1 power n. If n is even, then you get it as a plus 1, if n is odd, then you get it as a minus 1, then minus the answer, which is cos 0 value is 0, right. So, 1. So, it can be written as 1 by, that is either minus 1 power n by n pi minus 1 by n pi. So, this is the b n value. B n value is minus 1 power n minus 1 divided by n pi. So, this is the way we are obtaining the value. Now, by varying the n value you can get the coefficients. Suppose if you want to write the final expression f of x, right, how do you represent? A naught by 2 plus summation of n equal to 1 to infinite a n cos omega n plus summation of n equal to 1 to infinite b n into sin omega n, right. So, what is the a naught value? A naught value was 1. So, 1 by 2 plus a n value was 0, a naught value is 1. So, this term becomes 0, b n value was minus 1 power n minus 1 by n pi. So, summation of n equal to 1 to infinite minus 1 power n minus 1 divided by n pi into sin omega n. Okay. So, this way we are finding the coefficients A naught, A n and B n. Finally, we are representing the Fourier series. Now, find the Fourier series coefficient for this wave, that is minus 2 to 2, but the value is obtained only for 0 to 2. So, the time period value is 4. So, here I am giving the constants t and n. Then initialize the period time equal to 4. Then give the omega naught value equal to 2 pi by t, right, 2 pi by t. Then I have taken the n value 1 to 7. Then you directly write the formula A naught equal to 1 by t multiplied with integral of 1 comma t comma over the period 0 comma 2, right. Okay. Now, write the formula A n equal to 2 by t multiplied with integral of 1, f of t value is 1, then cos n multiplied with omega naught multiplied with t, then integral over t comma the limit 0 comma 2, then b n equal to 2 by t integral of 1, f of t value is 1 into sine of n star omega naught star t integral over t comma 0 comma 2. Okay. So, now save the program. Fourier series. Okay. Now, execute it. So, after executing you can find the value. Here we are taking W naught value, right, 2 pi by t which is 1.57, n value is varied from 1 to 7, that is 7 coefficients. Then A naught value is 1 by 2, A n values are 0, B n values are 2 pi 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 0, 2 by 3 pi 0, then 2 pi 5 pi 0, 2 pi 7 pi. If you are increasing the n value, you can increase the number of coefficients. So, in today's episode we have discussed about the Fourier series representation for continuous time signals. So, how to represent the continuous time signals and what are the Fourier series coefficients, then how to obtain by the mathematical expressions and how to write the MATLAB coding. Questions. First question, list the Fourier series coefficients for continuous time signal. Second question, find A n value for the given expression x of t equal to e power minus a t. With this, I will conclude this session. Thank you.